While the speed of the asteroid that smacked Mars wasn't much different than the one that hit the Yucatán Peninsula, the mass was many times greater, leading to a much larger release of energy.
Probably about 1 million times more energetic. So it would be about 250 million megatons of energy. And that's a lot of energy. And that's why you got such a big basin.
Something like that hitting Earth today would put the instant death toll in the billions and would probably wipe out all life on the planet soon after. But the next blast did blow an even bigger chunk of crust off our planet, luckily before life even existed here. Number 8, the Big Splat. Instead of Mars being a target, imagine an asteroid the size of Mars slamming into Earth. Most planetary scientists believe that's exactly what happened soon after the Earth formed about 4.6 billion years ago. It's known as the giant impactor theory, also nicknamed the Big Splat.
The early solar system was a much busier place than it is today. Basically, it hadn't settled down yet. So there are lots of fragments running around, producing all sorts of collisions, which ultimately produced the bodies we know today.
Earth was still a molten wasteland, devoid of life back then, which is a good thing, since the force of that collision would have ended life in its tracks. So how did the planet recover from the most violent event in its history? Many of the biggest blasts in the universe are caused by comets and asteroids slamming into planets. These impacts can unleash hundreds of times more energy than the entire nuclear arsenal on Earth. But number 8 on our list is even more powerful than that. A blast caused by a rock the size of a planet slamming into Earth. It actually happened soon after the Earth had formed, about 4.6 billion years ago, when an object the size of Mars, sometimes known as Theia, slammed into our world with catastrophic effects. Compared to the Pluto-sized asteroid that smashed into Mars, the Mars-sized rock that nailed Earth was more than 3 times larger, releasing much more kinetic energy.
The Theia impactor that knocked off the crust of Earth was probably about 10 times more powerful than the Borealis Basin impactor.
But this incredibly destructive force also had some very important benefits.
So when Theia impacted the Earth, it happened probably at a glancing blow. And in doing so, the iron cores of the 2 planets actually melded together and formed a larger iron core and a larger Earth. Now, Theia's mantle probably got completely blown off in this impact because it's a little smaller than Earth, and some of the Earth's mantle got blown off. So you have all this mantle debris floating around, orbiting, and it actually coalesced to form the Moon.
The Moon stabilized Earth's axis, preventing it from tilting wildly, which keeps Earth's climate steady. It also slowed Earth's rotation over time to the 24-hour days we have now. Once again, to simulate the power of this blast, an explosives expert places a charge on a melon representing Earth. Could this be the one that blows the melon away?
Even though there's a lot of damage, the basic structure is still intact.
With the heat of the impact, the Earth and the debris were both molten. And that molten state is the reason why the impact didn't leave a massive crater behind. The molten Earth reformed as a sphere, and eventually cooled. So is there any kind of impact that can turn a planet into dust? Number 7, when worlds collide. Deep in space, two planets, one the size of Venus, the other Earth, are on a collision course. They're rocky planets, possibly even harboring life. Something in their solar system has pulled them out of their regular orbits, and instead of a glancing blow, they smash together in a head-on collision. Anyone standing on those planets would have witnessed a terrifying event.
You can imagine if you had a direct view of the planet moving toward us. That means the sky would quickly fill completely with this planet about to impact, and then it would be over like that. It would be such a rapid extinction of lives that you probably wouldn't have time to think about it.
This isn't some fictional doomsday scenario. Some researchers think this massive blast rocked the cosmos within the last 1,000 years. In a binary star system about 300 light-years away. It's known as BD plus 2307 in the constellation Aries.
It has a tremendous amount of dust in it. 1 million times more dust than in our solar system. We think that this dust may have been produced by the collision of two planets, roughly the size of the Earth and Venus, just head-on, whack, shattering each other, producing a tremendous amount of dust.
It takes enormous amounts of energy for two planets to pulverize each other into dust. Now, instead of hundreds of times the world's nuclear arsenal, we're talking millions of times or even billions of times that energy. With this even larger charge, we're not just going to break off a chunk of this melon, we're going to blow it to smithereens.
But as terrifying and destructive as planetary collisions can be, they're still much smaller than the different types of blasts that come from stars.
It's a whole new ballgame. The main reason is that there's a lot more mass in a star than any planet-sized object. And then there are all kinds of mechanisms that can take place involving nuclear fusion or various processes that involve gravitational collapse, which can drive a lot of energy as well.
One of these energetic blasts is number 6 on our list, magnetar flares. Magnetars are rapidly spinning neutron stars, which form when stars several times larger than our sun begin to die and collapse in upon themselves. Imagine if our 865,000-mile-wide sun suddenly compacted to the 12-mile length of the island of Manhattan. All of that matter is condensed into something so dense, it's estimated to be 10 billion times stronger than steel.
To give you an idea of how incredibly dense neutron star material is, if this cap was filled with neutron star stuff, it would weigh 100 billion tons on Earth. More than this hill, as much as an entire mountain.